there's really two types of data you can collect. You can collect stuff that has to do with numbers, and you collect stuff that doesn't have to do with numbers. And two kind of fancy sounding words for that. It really doesn't mean anything besides numbers and non-numbers, or numerical and non-numerical. It's called qualitative and quantitative. Which one do you think doesn't deal with numbers? Yeah, what's the key word in qualitative? Oh, like the quality of something. It doesn't have to do with numbers. It's just like hair color or eye color. Give me some besides color. Say color twice. What else could it deal with? What do you think it's like? Not everyone at once, you know. Is all anything under my colors now? Okay, I'll break the ice here again. How about if you ask someone whether they're Republican or Democrat? Is that numerical based? Republicans are number one, Democrats are number two, vice versa. Democrats are number one. That doesn't really make sense, right? They're not numerical. You're either Republican or Democrat. Or something else, independent, Green Party, whatever else they have. Give me something else that's qualitative and not quantitative. I'm sorry. Perfect. Something else. Religion's a great one. Yeah, you can't put a quantity on religion or race, ethnicity. Anything else? I'm thinking of one more. There's typically only two of them. Gender, very important. Gender is something you can't really put a number on. You don't put a value or ascribe the number to gender or race or religion or Democrat or political preference. Things like that. So, let's call that qualitative. You know, some books call it categorical as well. Like categories. So qualitative data, what we're talking about is data that is non-numeric. And I think you guys gave some great examples. We talked about gender, that was good. Race, religion, let me ask you for one more, and let's see what you think about this, okay? What about, now we had all these things, what about zip code? Would that be qualitative or quantitative? What do you think? Now, it has numbers, but my question to you is, even though it has numbers, do those numbers mean something mathematically? For instance, if I take your zip code and your zip code and add it together, do we get someone else's zip code that's like, oh, this is related somehow? Does it make sense to do that? Does it make sense to multiply zip codes? How about divide zip codes? No, zip codes really are categorized in the United States in sections. That's what zip codes do. Bigger numbers are towards the west, smaller numbers are towards the right. East. Towards the east. That's how zip codes really work. So even though something might not have a number, or might have a number, might have a number, it's not necessarily quantitative. A zip code has a number, but it's still qualitative. Here's the big key. Right? Qualitative data is data where mathematical operations are meaningless. You can't really do math with it. Do you guys get the point of that? You can't add them or subtract them with one, but mathematical operations are meaningless. Okay, with that in mind, I'll give you another thing, another piece of data, another type of, or another item here that has numbers where math would be irrelevant to do math? What now? Well, age. If I took your age, and that was a good idea, but if I took your age and my age, and I subtracted them, is that going to tell you something about me and you? It's going to tell me that I'm older than you. So age not quite so much, but you're on the right track. Someone else give me another one where you could subtract them, and it wouldn't make a whole lot of sense to do that. Yeah, area codes, or even phone number. Very good. Someone else give me something else. You what now? Great. Yeah, they all have numbers, but if you subtract them, you don't get someone else. It wouldn't make sense. Very good idea. Did you guys get the idea of qualitative or non-numeric or categorical data? Give you a little head nod if you do. Okay. So it's right here, math operations don't make a whole lot of sense to do that. The other one, quantitative. What that means is it's numerical. So numerical data. I'm guessing you can give me a whole lot of things that are numerical where you can subtract them and things make sense, such as, I'll give you one, height. Height of is numerical. 6 feet, you're taller or shorter. If we subtract those, there's going to be some difference there, right? Which is meaningful. It says, I am taller than you or shorter than you. So something like height would be quantitative data, or weight. I'm talking about like pounds, not like weight. Anything else on here? Come on, think some. Think some. Guess that jobs. Hopefully this job should be made. Somebody else give me one more and we'll stop. We already have income, we have miles per hour, we have height, weight. What happens when you get up in the morning? Maybe you check weather for this item. Temperature. Temperature as far as degrees, right? If it's 98 versus 91, that difference in temperature tells you something, doesn't it? Sure, absolutely. Now, I don't mean like morning, afternoon, night, but I mean like 3:30 versus 4:15. The difference between those is 45 minutes. We have something that relates to. So times are very good examples. Very good. And essentially, it's the opposite of this statement. Whereas mathematical operations are meaningless here, they are meaningful here. That's really the only difference. Math operations are meaningful. That's good for calculators. Shows what's false. No, I'll never give you the wrong answer. I'm too afraid. Please, Steve, don't throw me again. I promise I won't do it. Wrong answer. Now, within quantitative or numerical data, we do have a couple types of those. We have things that are discrete data, and we have things that are continuous data. Let's talk a little bit about that so you know the difference. So, two types of quantitative data. Types of quantitative, I'm abbreviating there, data. The first one we'll talk about is discrete data.